programs. So, I mean, in essence, so okay, you've got the development environment here, but okay, so again, you can see kind of here an example of many different platforms running on this thing. We have a whole bunch of terminals literally being written all at once to be able to access this service, in addition to the terminals that were originally there when we started, which was for Windows PC and Linux and Mac. But you also have mobile clients coming up as well. So there's a lot of accessibility here. Well, what was Plato? Plato was a legendary time-sharing system that was developed for educational purposes by the University of Illinois. The project started in earnest in 1960 and got really going under the steam under Herb Alpert and directed by Dr. Donald Bitzer in 1962 and ran pretty much continuously from that time until the Plato spinoff Novanet closed its doors in 2015. Now, I will take and put a post-mortem here that the vast majority of the content that had been created had been ported over to a new system called Edumentum, which still exists and is running at edumentum.com. So, you can see here a lot of example screenshots here, and you can see just right off the bat here that we're dealing with a very unique service with more than you would consider from time-sharing services of the time. Now keep in mind, you're seeing graphics, you're seeing touchscreens, you're seeing touchscreen interaction here, and all of these things were actually active and running by the mid-1970s. Plato was home to a whole host of incredible innovations. You see here 2 example Plato terminals. You can see that these have orange gas plasma displays. And in point of fact, the gas plasma technology was actually developed by the Plato team specifically for the Plato project. Because at the time that Plato was starting up in the mid-1960s, memory was costing $2 a bit. $2 a bit. And they wanted to be able to produce a full graphical display, but they didn't have the memory. So the solution was to create a display technology in which the display itself had its own inherent memory. These displays also have, you can kind of see underneath the lips and the bezel here, a touchscreen element so that you can take and touch onto the screen. Pretty much a precursor of how we use our machines today. There were tons of innovations that came out of this system, even notwithstanding the hardware. Some of the first threaded discussion forum systems were developed on Plato. Many multiplayer gaming ideas were also developed on Plato. 3D flight simulator systems like Airfight presaged Bruce Artwick's work on Flight Simulator and Flight Simulator 2, for example. Avatar. Games like Avatar and Oubliette presaged the development of games like Wizardry and Ultima, and on and on. There are many, many more. The first implementation of threaded discussion forums in the form of Notes. If the name Notes sounds familiar to you, that's because one of the systems programmers on Plato, Ray Ozzie, went on to Lotus to develop Lotus Notes using much the same methodology. So that started here as well, and much more. Now I will take and take this opportunity here in the middle here to give a big thank you to the people at cyber1.org. Cyber1.org is the other major extant and much older extant internet accessible Plato system, which can also be accessed through their software and the software that Errata Online provides for its terminals as well. But without their efforts of getting all of the necessary copyrights, getting all of the necessary legal clearances to be able to take and bundle up what they were running on their system as a usable distribution, I would not have been able to actually do this service and provide this for you guys. So I want to take a moment to basically thank them profusely for the hard work that they did. I stand on their shoulders. If you want more information about Plato and its history, which is a bit beyond the scope of this talk here, I could go on for hours on this alone. I highly recommend that you pick up a copy of Brian Deere's book, The Friendly Orange Glow, because it provides a complete historical account of Plato and the people who designed and used the system. You can read more about the Friendly Orange Glow at its website here, www.platohistory.org. And I want to take this time here to mention that Brian Deere's book is the initial motivation behind me providing and building up this system for the retro computing community. So I want to take this time to thank him as well. Now, a little bit about what's actually being done here. This is an actual Plato system running on emulated hardware. A little bit about the system that's the emulated system that's being run here. Plato ran on Control Data supercomputer hardware. Specifically, a Control Data Cyber 170, 865 in this case. This was a machine that had 60-bit word size. That means 60-bit register size and memory size. To that effect, it had approximately 1 megaword of memory, which also doubled as its extended core storage as well. The machine itself, this particular machine has 1 central processor and 24 peripheral processors, which handle all of the I/O to and from the system. Moving outward from that, the emulated system is running on top of Control Data NOS version 287, and the Plato system is running as a series of jobs running on the various central processors and peripheral processors on top of that. Moving outward from that, the system itself, the actual hardware, is a fairly standard commodity PC that is running the emulator, which is Tom Hunter's excellent DT Cyber package, which is providing the connection to and from the emulated system and the outside world. So an actual TCP connection is provided into the system and capable of handling many multiple connections. If I wanted to, I could take and crank all of the internal parameters up and handle several hundred users at the same time, all without breaking a sweat. And that really is the irony of this of this whole setup here. This incredible system that took up an entire room worth of equipment is running on the teeniest, tiniest corner of one of the server PCs in my lab on a single core. So now that we've kind of gotten a quick introduction out of the way here, I will actually take and now go through a bit of a demonstration here showing multiple terminals and how the system is actually, a bit about how the system is actually used here. I will go ahead and actually log out of this guy real quick and log back in so you can kind of see the login process here. Now, there is actually a website. Because of the interests of presentation here, I'm not actually going to show the website, but you can get... Yeah, I'm still here. 1, 2, 3. Are we here? I'm here. Did everything stop the moment that I pulled up an emulated screen here? 1, 2, 3. Can you guys see me? Hello? Yes, I'm still transmitting. Yes. Yes, I am still transmitting and recording. I can still hear you guys just fine. Oh boy. Well, if need be, I can reconnect. All right, I've reconnected. Can you guys hear me? See me? One, two, three. Hello, I'm still here. I can still hear you.
Sure. I mean, we have a hotspot, but if you've got a better one. Grandfather unlimited. Okay. All right. Which one do you? Which one do you? Take those from.
Okay. Oh, the benefits of modern technology. I'm losing valuable. Okay. I can see video.
Oh, there's two of us here.
Yeah, you got it good. Yeah, I can hear you fine.
Okay.
I wonder what happened.
Okay, so you're now back. You're back online.
Okay, cool. So we're kind of interesting that we stopped at that point here because that's an earmark for the demonstration here.
We lost you right when you were switching to the demonstration, so you're good to go.
Okay, let's make sure that we still stay stable here. Can you guys see that? Okay.
Yes.
Okay. So, in the interest of brevity here, I won't go through the website, but the website contains everything that you need to get started with this service. It gives you the ability to take and create an account. It gives you the guest information so that you can log in as a guest account. It gives you all the software that you need to install a terminal. And it also provides a technical section detailing virtually every square inch of what you would need if you wanted to write a terminal for another machine. And it also contains a wide variety of demonstration videos showing various aspects of the system. So once you've actually created an account, I will take and receive the notification that we've received the account, and an account will be created, and you will receive an email back. Once this has happened, you can then log on. And in this case, we'll go ahead and log on here with username and the group. At this point, you enter in your password, and you're presented with a menu like this. Now you can already tell that we've gone way beyond the constructs here of VT100ism here. We have graphics, we have color for terminals that support it. One thing to note here, you can tell that the colors of the Apple logo are correct. There's a reason for this, and that's because that Control Data, when they added color to this terminal, in the mid-1980s. They specified a 24-bit RGB color model. Whether that was insanely lucky or an incredible amount of foresight, I'd like to find out for sure. So you'll notice here that on this particular screen, each of these items, you can either press a letter or select one of them with your touch to go to a particular menu. There are also a number of special navigation keys, which you can get to on each of your terminal programs by, for example, going into Help and pushing P-Term Keyboard. And it will give you a list of all the keys here. But for the sake of brevity, I will only mention here that each of these keys are mnemonic, typically in all these terminals. So back is Control B, data is Control D, etc. So we'll go ahead and click back here and just kind of quickly go through some of the bits and pieces. If we go into the catalog, for example, you can see over 16,000 different lessons that were created for the system over a period of roughly 25 years on subjects ranging from high school biology to, and I kid you not, how to operate a nuclear reactor. Don't believe me? Let's find it here. Let's search by subject and look here, and we have a number of subjects under nuclear waste treatments, nuclear magnetic resonance spectroscopy, and all the way down here until we see options number 11 and 12 for nuclear reactor operators and training. Let's go ahead and go straight to option 12. We can select option 1 here, see a synopsis of the particular lesson, and we have the ability to be able to try it. Oops, apologies, Shift Lab. And there we go. We can see a Nuclear Utility Training Series demonstration package. So it kind of gives you an idea of the types of customers and the breadth of education that Plato was actually trying to solve. At any given time, if you want to take and go back to the beginning, you can press Shift Stop, which acts as a panic key, and give you the option to be able to continue working, or hit Shift Stop again to sign off. The stop key, of course, as Mick sort of alluded to earlier, is Control S. It's mnemonic. We'll go ahead and press Control D for data to continue. And just as a quick little dip into the game section here, let's go in and you can see a wide variety of games. Selecting one of them gives you kind of a quick synopsis here that you can say, okay, yeah, that looks good. I'll take and press to play that. We'll go ahead and press data to play. This is Airfight. Airfight is a 3D flight simulator. Note the copyright date on the bottom here, 1976. This was written by a grad student at the U of I at the time, Bran Fortner. Bruce Artwick undoubtedly saw this and was inspired to do his computer graphics and flight simulator work for the PDP-11 and eventually the Apple II and other machines, culminating in today's implementations of Microsoft Flight Simulator. So you're literally seeing the beginnings of all of this. We'll go ahead and select one of the fighting squadrons here and select a plane. And you can see that each of these planes have a number of different characteristics here, which factor into the flight physics. How much empty weight there is, payload, how many missiles you can pop on, how much fuel you can put on, etc., as well as factors for maneuverability and the like. So we'll go ahead and give ourselves a call sign here, and we'll go ahead and give ourselves 8,000 pounds of fuel, put ourselves 10 missiles in here. Now this is a multiplayer game. That means that other players that are in here, your objective is to take and shoot them down in a dogfighting scenario. So we'll go ahead, bring up the flaps here, go ahead, crank back the throttle, pull back the stick, and we'll take off. And you can see right here, with a suitable connection, you can see a full first-person flight simulator experience. I'm going to take and crank the rudder back a little bit here so you can see there's our runway going back from us here. Neutralize the stick, etc. And at any given time, you can take and look at the map to see where you are on the airfield here, where you are in relation to the other enemy runway and any other enemy planes. You can also get information on players, and you can also take and send messages back and forth here. You can see there's a message from an earlier gameplay up there on the top left-hand corner. So that kind of gives you an idea of Airfight. Now, for the other side of this, we'll take and go quickly into a game of Avatar. Avatar is a multi-user dungeon, one of the first. Again, if you note the copyright dates, it starts at 1977 and continues on through the mid-80s. Right now, I'm inside one of my characters, and I'm inside the city. We'll take and go ahead and take the train down to the dungeon here, and you can see that we're moving around in a first-person simulation here. And to further take and pull this across here, I'm actually going to take and switch to another system here, which is running on the Commodore 64. And you can see pretty much the same experience here, just sans color and paint. But we'll go ahead and go into the games section here. And we'll go ahead and go into Avatar here. And you'll be able to see here just a little bit less. We're running this at about 1200 bits per second here. And you can see the dragon being drawn. But already here you can see the potential here for artwork, because all of the artwork that was drawn here for Avatar, as well as other programs on the system, were actually drawn using the built-in screen editing functions that are part of the development environment. And one of the things that it's actually doing here is it is sweeping out the dungeon. It's actually taking and loading the character set into the terminal here to display the maze graphics. And this is part of the reason for the performance that you're about to actually see here, and why this actually works extremely well. We'll go ahead and come in. We already have a character defined here. And Sam should already be down in the dungeon as well. Yep. And we're both in the game together here. And you can see even here at 1200 bits per second that the performance is actually quite good, as you can see. So that kind of gives you, an idea. And to really further just kind of hammer this across here, I'm going to go over here to what is a ZX Spectrum, running the same software. And actually, we're going to take and hard reset the machine here. This particular machine has what's called a Spectranet, which is a hardware Ethernet device. And one of the things that Spectranet can actually do is load a copy of software over the internet. And I have a copy of Platoterm on a server specifically for Spectrum users, which can be loaded directly over the internet, as you can see there. Go ahead and log on. And you can kind of already see that the Sinclair version has a bit of color to it. We'll go ahead here, log in. Apologies. Okay, try that now. And you can see much the same experience, but of course, because this is running over Ethernet, the display is even faster. So you can see this is even running on a Sinclair ZX Spectrum here. Now, for my final demonstration, I'm actually going to bring this home, and we are going to do a mini platform demonstration. Give me a moment here to set this up real quick. Make sure that I can see the display just fine here. Okay. So one of the functions that's available to users of this system is the concept of talk and conferencing. Of course, the usual chat function is there, so you can talk amongst a small group of people. You also have what's called Term Talk, which allows you to take and do one-on-one conversations, instant messages with people on the system. But you also have what's here is a conferencing feature. And that means you can take and have a bunch of people connected together using the screen sharing feature that is also actually a part of Term Talk, and to be able to share that screen across multiple machines. And I'm going to use this to demonstrate the cross-platform nature of Errata and all of the terminals and what I'm actually and the big picture of what I'm trying to accomplish here. So we'll go ahead and look real quick at the list of names that we have here. We have 4 users in my conferencing list, all from different groups, just a mishmash, and I want to take and collaborate on some code perhaps. So for this, we will actually go down here to what we call my mini plat scene, and you can see that we have a whole bunch of connections happening to Errata here at the same time. All different machines: Commodore 64, ZX Spectrum, Atari 8-bit, Apple II, and Windows, Mac, and Linux. There are a few more actually. I just didn't want to make the thumbnails too small. So we'll go ahead from this point here and go ahead and start the teleconference. Now, since all of these users are online, they will immediately receive notifications at the bottom of their screen that the teleconference is ready. And you can start to see them appear. One by one, they're answered. We answer with the term confer. We go ahead, now Bob has joined the conference, and we can start to see the status updates be updated here. We do the same thing over here on the Atari side. And for the Sinclair. And finally, you'll notice that the Commodore is actually still playing the game of Avatar, but he received the Term Talk anyway. And you can think of terms inside the system as desk accessories on steroids. There are a lot of little functions that you can use to have access to system functions no matter where you are inside the system. Finally, now that everyone's in attendance, I can go ahead and start the conference. We'll go ahead and do that. Now, since I'm over here in the authoring environment and I'm conferencing across, the authoring environment is then automatically sent to every participant in the conference. It doesn't matter what I do from this point, everything is automatically sent across. I could go show what I'm currently working on, which is an Othello game. And again, everything automatically sent across. Or I could go into the development environment for this game. Go ahead and do that. And it goes ahead, loads the character set in for each of the participants automatically, and brings everybody into the editing environment. Not only that, but now I can start to do more interesting things. Let's go into the character set editor here. And you can see that the system tries to take and catch everybody up as best as it can. I apologize for the slight glitches here that are happening. It's literally because I'm running multiple emulators at the same time. But we can go ahead, for example, look at a single character. So you can see, so long as the terminal is implemented, every user has access to every single feature inside the system. The graphic editors, the code editors, it simply doesn't matter. Now at any given time, anybody can take and talk and ask a question. And of course, I can answer. And so on. Not only that, but I can also take and pass the baton over to someone else. So let's say, for example, I can do the term transfer, and I can transfer to a new user. In this case, I'm going to transfer over to Sam on the Commodore 64. And at this particular time, we now get the indication that Sam is the conference leader. And when I refresh the display, we can see that the game of Avatar that Sam was playing is now taking and bounced across to the other participants. And so on. Of course, what looks like we need to take and reload the character set for some of these. But that's okay. Let me see if I can actually tell it to reload characters. If not, no big deal. Okay. Loading character set. And you can see that once we do that, everybody should be updated in just a moment. Give it a few more moments. Okay. And now that we've updated, now we can see the result. And it looks like we've temporarily lost the, looks like we may have lost a couple more of the participants here. But that's okay. It's kind of the, well, no, okay. Just had a bit to catch up on. But as you can see here, you can already see the power of the system here. So with that, that's my impromptu demonstration here. I had to take and cut this a bit for time. But what are the opportunities that are available? Well, there are a lot of opportunities. Of course, users can use the system, and I encourage more users to use the system. Anybody who can hook up a Wi-Fi modem is encouraged to their machine, is encouraged to participate. But there's also a significant opportunity for content authors, because the system, like I said before, has a built-in development environment baked right into the system that allows you to create single or multiplayer games or unique forms of content that can instantly be distributed across to many different platforms, as you saw before. And as far as authors are concerned, not just programmers, but artists can also get on the deal, because there are graphical editors for character sets, as well as a screen designer that allows you to use your mouse or touch screen to take and draw shapes, figures, etc. that get translated into code and back again. This is how the dragon in Avatar is drawn. Not only that, but there's opportunities for system staff as well. I need people to help take ownership of the various subforms in the system. Right now, for example, we have just going back here, for example, we have notes files for a variety of subjects, such as Atari-related notes files. We have notes files for Commodore 8-bit, Commodore Amiga, TI-99/4A, etc. And you can see inside here, it looks like any threaded discussion forum that you would expect. So on. So there are opportunities for people to create new threaded discussion groups and all sorts of interesting things. And lastly, there are also opportunities for archaeologists, meaning that there is approximately 30 years worth of code that needs to be discovered, functionality that needs to be understood and resurrected. To give you two examples, there is a fully functional Kermit implementation sitting on this system, which meant that they already had facilities for doing file transfer between microcomputers and the target Plato system. But also there are facilities for transmitting, for example, notes files back and forth between different Plato systems. This needs to be rediscovered and figured out how this works. There are whole authoring systems that were made because Plato actually, in addition to the centralized Plato system that was available, there were microcomputer variants where lessons were created and authored on this system to be distributed on target floppy disks for different systems, such as TI-99/4A. And Atari, and Apple II, etc. The authoring systems for those systems are actually sitting on my system as well, and on CyberOne. Not only that, but there is also an opportunity for what is called MicroTutor. MicroTutor is an implementation of Tutor that runs on the local machine as an interpreter that allows you to take and not only run bits of pieces of code locally on your machine, but also to communicate back with the central Plato system, sending state information or whatever you want to send back to the central system and back again. So this opens up a whole new possibility for more arcade type interactions, for example. All of this needs to be studied, and solutions need to be made for all of these different systems. And in the text section on the website, for example, there is not only protocol specifications, but there's also source code showing all of the various different, for source code for MicroTutor, for Z80 and 8086 assembler, which can be brought in and ported over to other systems as well. I'd love to see one for 68,000, 6809, etc. And so on. And even better, possibly a portable implementation written entirely in C. The possibilities are endless here. So again, we need, of course, users and authors. And of course, we also need terminal programs to access this service. And to that end, I've actually been doing a lot of work taking and creating and implementing a portable implementation of a Plato terminal written entirely in C. You've seen the results throughout this demonstration here. The same code base is used for multiple targets at the same time. And we would love people to take this portable implementation and help take and port this over to other systems. On average, I'm able to do a bring up of a new system in under a week. I did the initial bring up on the ZX Spectrum from 0 to working in roughly 3 days. We also need, we have terminals for being written or have been written for a number of these systems. There's even more that need to be added to this list. For example, classic IBM PC and PC Junior. I'll be working with Jim on that particular port. And yes, I explicitly want to be able to support the PC Junior and its 16 color graphics mode. A number of other systems have been added to the list since I initially wrote this list a couple of months ago. We've gotten, of course, ports working on the ZX Spectrum, but also the Amstrad CPC. And I am putting together toolchains for other systems, such as the Thomson MO5 and TO7 for the French users, and so on. So I want to take and tidy this up for questions here. But before I do that, I want to take and give thanks to all of these people. Most importantly, to my wife and daughter for tolerating this extreme obsession that I have burdened myself with over the last 6 months. Also to Tom Hunter for his excellent work in putting together the Cybus distribution and the DT Cyber emulator. Joe Stanton for running cyber1.org and the website of cyber1.org. Paul Koning also helping with the distribution. Steve Peltz. Steve Peltz's PAD implementation is the protocol decoder that's used for all of these implementations of Plato-Term. Steve Cox and Steve Zoppi for testing. Michael Sternberg for his excellent work in reverse engineering the Atari Plato cartridge, which was one of the only commercial implementations of Plato that actually made it out into the wild. The work there allowed us to take and create a portable implementation of the character set scaling algorithm that's now being used in all these different versions of Plato-Term. I also want to thank Jeff Thiel, an early fan here, for helping to test and to really get to know the system extremely well. I also want to thank Evan and Jim and all of the various facets of the Vintage Computer Federation for allowing me to take and demonstrate this and bring this out to the retro computing public. And last but not least, I want to thank all of the users who are signing on and using this service. What will come of this project, I really don't know, but I want to take and try to facilitate as much as I can and on behalf of the interested users and developers and archaeologists to try and make something truly unique to come out of this particular system. If you want to know more, there's the website, www.errata.online. It gives you everything you need to get started with this particular project. So with that, I will take and stop here and open up for questions.
Can you hear me okay?
Yes, I can hear you fine.
Okay, I'm going to turn on the microphone. Does anyone in the audience have any questions for Tom? Okay, so let me turn on the mic.
I don't know if you can hear this. Can you hear this okay?
Kind of.
Kind of. All related questions. Hey, Tom. So, as far as I understand, Errata and CyberOne are two different branches of the Plato system, right?
Correct.
So, what is, I know that it was a later implementation. Are there things, as far as you know, on this implementation of Errata that is exclusive to that, apart from the later stuff, but things that have been carried over from the old Plato system that did not have not implemented specifically on CyberOne?
Okay, let me answer the. So basically, he asked here. He asked for verification that Errata and cyber1.org are indeed two separate Plato systems, but also asking whether there are things that exist on CyberOne that do not exist on Errata and vice versa. And the best way I can take and the best way I can basically take and describe this and describe this, Cyber One and Errata Online are two different Plato systems with two very different aims. The cyber1.org system has a lot more content on it. And that's because they've managed to get permission from a lot of different people to host their classic Plato systems and have resurrected these things from various different tapes. They did not get permission to take and put these things into the distribution that they eventually built that Errata is benefiting from. So, I mean, and I'll go ahead and kind of carry this a bit further and state that even though we have two separate Plato systems, they actually service two completely different crowds. Cyber1.org is meant for the Plato expatriates of the original Searle Plato system, Searle and CDC Plato systems that were deployed back in the day, so to speak. And they're quite happy with their user base, and their aim is to take and produce an author experience for each one of those users. So the users there are quite comfortable of using the authoring environment there to take and navigate around, to do what they need to do, and to access the content that they have there. I wanted to take for Errata and produce a menu-based system that you could also take and bounce into the authoring environment if you wanted to, so that retro computing users would have a better time to be able to navigate the system, but also am trying to take and produce a whole bunch of new content and to facilitate the production of new content by interested authors for the benefit of the retro computing community. So those, two different systems, two different aims, two different sets of content, and you can think of them literally as two different cities on the map.
Thanks very much for your time.
You're welcome. Again, I apologize for not being able to make it there this time, but hopefully I was able to take and spur enough interest here from this YouTube presentation, technical issues notwithstanding.